Next set of problems involve logarithms that you have to exponentiate. For number 19 through 22, life is a little bit easier because you're just using the one-to-one property. So for number 19, I have log base 15 of negative 5x minus 1 is equal to log base 15 of 8 minus 4x. Well, because of the one-to-one property, I know that the logarithmic expressions are equal to each other because the two logs have the same base. So this is just negative 5x minus 1 is equal to 8 minus 4x. And so from here, we just solve for x. So I'm going to add my 4x over. This gives me negative x minus 1 equals 8. I add my 1, so negative x is equal to 9. So x is equal to negative 9. And for 21, you will do a similar process. The only difference is we end up with a quadratic. So we have log base 2 of n squared plus 18 is equal to log base 2 of 8n plus 3. So from here, I know that my two expressions are equivalent, so I have n squared plus 18 is equal to 8n plus 3. And with any quadratic, my starting point is I have to get it equal to 0. So I'm going to subtract my 8n over, and I'm going to subtract my 3, and I'm going to set it equal to 0 to solve. And then once I'm here, I have to factor it. So when I factor this down, I need two terms that will multiply together to give me 15, that add together to give me negative 8. And so since this is positive and this is negative, I know that both of my numbers are going to have to be negative in order for that to work. So this is going to factor into n minus 3 times n minus 5 is equal to 0. And so when I solve this, n is equal to 3 and 5. And anytime you end up with more than one solution, you always want to substitute back in just to make sure that the solutions work and make sense. And if they don't, then that ends up being an extraneous solution and it's not a true statement. So in number 23, we have log base 3 of n equals 4. Now from here, what you're going to have to do is you're going to have to exponentiate. So what that means is you're just going to rewrite this as an exponential and evaluate it. So this means 3 to the 4th power is equal to n. So at this point, you're literally just going to evaluate 3 to the 4th power. So n is equal to 81. For 25, we have log base 5 of x plus 9 is equal to 0. So we exponentiate. So this is 5 to the 0 power is equal to x plus 9. Well, anything raised to the power of 0 is just 1. So this is 1 equals x plus 9. So x is equal to 10. For 27, we have log base 12 of 5 minus 7x is equal to negative 1. So I need to exponentiate, so I have 12 to the negative 1st power is equal to 5 minus 7x. So this negative 1st power means I'm actually going to have a fraction. So what this means is 1 over 12 is equal to 5 minus 7x. So I need to solve for x, and to do that, I'm going to subtract 5. So I have 1/12 minus 5. This becomes negative 59 over 12 is equal to negative 7x. And then I'm going to divide both sides by negative 7. And this will give me x is equal to, it ends up being 59 over 84. But we're going to round it off. So x is going to be equal to 0.7024. In number 29, we have 10 plus the log base 8 of n is equal to 13. So I'm going to subtract 10 from both sides to isolate my logarithm. So log base 8 of n is equal to 3. And then I exponentiate in order to solve. So I have 8 to the third power is equal to n. And n is equal to 512. For number 31, same song, different dance. We have log base 6 of negative 4m minus 8 equals negative 5. So the first thing I'm going to do is I'm going to add my 8, and this gives me log base 6 of negative 4m is equal to 3. And then I have 6 cubed is equal to negative 4m when I exponentiate. So I have 6 cubed is 216 equals negative 4m. And when I divide both sides by negative 4, this is going to give me m is equal to negative 54. For 33, we have log base 5 of negative 7b minus 6 plus 1 equals 1. So the first thing I do is I subtract 1 from both sides. So I have log base 5 of negative 7b minus 6 is equal to 0. So when I exponentiate, this gives me 5 to the 0 power is equal to negative 7b minus 6. So anything to the 0 power is 1, and then I'm going to add 6 to both sides. So this gives me 7 equals negative 7b. And when I divide both sides by negative 7, this is going to give me negative 1. For 35, we have 6 times the log of x plus 10 equals 4. So I'm going to subtract 10 to get 6 times the log of x, not base x, log of x is equal to negative 6, and I divide both sides by 6, and this gives me log of x is equal to negative 1. Well, this log means a common log, so its base is 10, so that means 10 to the negative first power equals x. Well, that negative 1 means that x is actually equal to 1 over 10, which is 0.1 as a decimal. For 37, we have 8 minus 5 times the log base 3 of negative b equals negative 7. So I'm going to subtract 8 to get negative 5 times log base 3 of negative b is equal to negative 15. And when I divide both sides by negative 5, I get log base 3 of negative b is equal to 3. So that means 3 cubed equals negative b, and 3 cubed is 27, so b is equal to negative 27. And for the last one, before you try them on your own, number 39, we have 1 minus 7 times log base 5 of 9x minus 2 is equal to 15. We subtract 1 from both sides, so I have negative 7 times log base 5 of 9x minus 2 is equal to 14. And I divide both sides by negative 7, so log base 5 of 9x minus 2 is equal to negative 2. So from here, I exponentiate. 5 to the negative second power is equal to 9x minus 2. And then I add 2 and divide by 9 to end up with x is equal to 0.2267.